Lately, even if you're not here, I'm still scared of this. So let's get this done. Get over with this. Okay. So you wanted me to say you like, oh fuck, shite. Yeah. Wanted me help with what is a. You know what? Wait. Yeah. So you wanted to teach me pathogenesis, right? This thing. So this is the molecular mechanism. Okay. So I thought that okay, I've seen this somewhere. Okay, and to be honest, where I've seen this is tada, the neoplasia chapter. Since our class is going a bit slow, so I could remember this stuff. Okay, so I'll just explain this thing to you first. Okay, and from there we'll go over here, connect these both, and this table also is a little bit good. Okay, for it will help you, and then we'll wrap it up with a list of stuff. Okay, you know what, let's just not wrap it up with a list of stuff. So starting with the growth factor, how so melanoma, it's a very much dangerous disorder, many people have it. Okay, and UCV actually, like, her face had that and she got it cut off. It was benign though, so yeah, whatever, just something new. Okay, so before all this, we have to learn about what are the ways which can affect, like how does it come about. So obviously either your cell cycle, your promoters will be increased, or else your tumor suppressor genes, that decrease, right? So oncogene, basically oncogenes are increased. So this one. Okay, so your first one is a tumor suppressor gene. Okay, is a tumor suppressor gene. Okay, and that's your CDK. What was it? Sorry. Yeah, CDKN2A. Okay, CDKN2A. So what is CDKN2A? It's a locus. Okay, what is a locus? You know, right? A locus is a position on a chromosome. Okay, I don't know which chromosome. So a locus which gives three types of gene products: P15, P16, and P14. Now you'll say, why didn't I write 14, 15, 16? Because in a book, P14 is given as ARF, but P14 ARF is also called as P14. Okay. So basically, P15, I couldn't find its use. I didn't search it. Wait, I'll just search it later. P16 is a CDK inhibitor, CDK4 and CDK6 inhibitor. Okay. Now its use I'll explain to you in the retinoblastoma gene. Retinoblastoma gene. దాంట్లో దీని యూజ్ ఉంటుంది. ఓకే, I'll say you that. Wait, okay. And ARF gene. ARF genes inhibit something called the MDM2. MDM2. I'm sorry, Ray. I really I just now revised it all, but I don't know. I just forgot everything. So we'll go a little bit slow right now. But once you learn all this thing, it will be easy as fuck. Okay. So yeah. So what does P16 do? What does P16? It emulates this one. So what does it do? It will cause how will inhibition of this cause something, right? So we have this, right? I think you read this flow chart. If there is a growth inhibitor, okay, what does a growth inhibitor do? Okay, it produces P16. Okay, P16, aka the CDK inhibitor. Okay. By the way, there's one more CDK inhibitor, P21, which is not done by these, and it's not done by these all. Like these three are by CDK and 2A, right? But this is coded by something else, P21. But right now not needed. Okay, see, growth inhibitor increases CDK inhibitor. What does it will inactivate? Okay, inactivate what? It will inactivate cyclin. You know, right? Cyclin D with 4 and 6. Okay, CDK 4 and 6. So what will happen? Hypophosphorylation. Remember that hypophosphorylation of RB gene. So since RB gene is hypophosphorylated, it will not release Okay, your transcription factor. What was it? E2F, right? Something. Transcription factor. I'm sorry, I forgot all that. Okay, but you know, right? Fat. This is what is it. MDM2 is something which denatures. MDM2 denatures P53. So your ARF will inhibit MDM2 from inhibiting P53. So you got this. That's a role of P16 and P14. Okay. After this, all second, okay, are the oncogenes, right? Okay, I'm sorry. Yeah, oncogenes. Everything is oncogenes from now. Okay. So what are the oncogenes, right? What are the oncogenes which is there? Okay, let's make a indefinite table. Okay. Like I think more are there, but yeah, we'll go. So you understood this, right? P15, P16. This is tumor suppressor gene. P14, MDM2, which denatures P50. P14 is ARF. ARF inhibits MDM2, which whose role is to denature P53. Okay, and then we have this P16, which is a CDK4/6 inhibitor. What does it do? Growth inhibitor. This whole thing, this whole story. Okay. Now oncogenes. Yeah. Now before coming to oncogenes, let's play here a little bit. Yes. So this was a thing in that we actually had it. Okay. Oh my God! I can. What is this? Oh fuck. Okay. Nice. Yeah. So where was I? Yeah. So where was I? Right? Yeah. So where can we like act such that it will cause excess of this pathway? Okay, one is your this growth factor receptor. Okay, if something happens to this, now in your melanoma, the melanocytes, okay, melanocytes, right? Yeah, they have this thing called the KIT. Okay, KIT receptor. Now KIT receptor upregulation could cause this. Okay, so right here in oncogenes, first one is a receptor, KIT receptor upregulation, or else anything mutation in that. Don't write upregulation, mutation in that. Okay, that's one. Okay, after KIT comes a RAS. Okay, now how does the RAS work and all? First we'll learn that. Okay, now see, whenever a growth factor comes over here, okay, it binds to this. It binds to the growth factor receptor, and this bridging this will cause inactive to active RAS. Okay, see how this GDP is there, right? It will form GTP. I think this was there in that GI, you know, right? G protein coupled receptor pathway, like that one. GDP becomes GTP. Okay, and then what happens is that downstream the active RAS, okay, what will it do? It will cause increase in, okay, now remember carefully, now actually, you know what, I feel it's better if I draw it for you. This was your receptor and this was your this is your growth factor. It causes inactive RAS to become an active RAS. How much is it? 8 minutes, my God. Yeah, active RAS. Now active RAS will do two things. Okay, over here it will cause an increase in the RAF pathway. Okay, and it will cause an increase in, come on, say, which is that? PI3K AKT pathway. We have to just remember that. Okay, see, RAF. Now in your melanoma, it is not RAF, it's BRAF. Remember that. So if you I'll just draw it with other color. Ta-da. Okay, now what happens is that your RAF is the MAPK kinase. Okay, it activates, it does a transcription, causes MYC and D cyclins. Okay, so RAF causes transcription of some proteins. Which proteins are those? MYC and cyclins. Okay, cyclins. Now your AKT pathway, on the other hand, PI3 will give AKT and mTOR. Just remember that, and it causes protein synthesis and pro-growth metabolism. Okay, so remember it as this: PI3K, AKT, mTOR. Okay, This is going to happen in the line. You have to remember it, and this causes protein synthesis, which is important for your growth. Yeah, got it. MYC also does that over here. Okay, MYC also does the same thing, protein synthesis. Well, cyclins, what do they do? D-cyclins, cell cycle progression. Okay. Now, once you got this, okay, something I didn't touch up over here was the P10. Okay, P10 is a tumor suppressor gene. How? Prem sir, why is it tumor suppressor gene? Why not oncogene? Because see, here this is RAS. How do you define what is an tumor suppressor gene or oncogene? If some genes increase will cause you to form a tumor, then that's an oncogene. If some genes decrease will cause tumor, that's called tumor suppressor gene, right? Okay, now P10, I'm saying what does it do is, see, it will inhibit PI3K pathway. Okay, P10 will inhibit, see, this is inhibition. Now here also I'll just draw it with some other color here. P10, okay, remember that. Okay, so we can say P10 also is one of them. So in tumor suppressor gene, I wrote here one, right? Okay, second one can be P10 mutation, P10 down regulation. Okay, nice, we are going good. Next, so one is a KIT up regulation. Now what can go wrong over here is that sometimes your PI3K AKT pathway may be upregulated. Okay, sometimes a BRAF may be upregulated. So yeah, see. Now what happens here? Now RAS may be upregulated causing this, or just the PI3K. Okay, sometimes the P10, see, PI3K, AKT, mTOR, survival. Okay, I said about MDM2, right? MDM2 is not related to anything. Okay, it's just that see this MDM2. Okay, it is by some gene. Okay, ARF will inhibit this. Okay, but MDM2 inhibits P53. Okay, see this one. Now you got this part and you got this part, right? RAS code. Okay, so your second is your RAS pathway. RAS pathway, it could be. Okay, and one more thing, many times when your PI3K pathway is aberrant, most of the times a BRF pathway is also affected. That I don't know how it's given that. So sometimes you might think only a PI3K pathway is mutated. Okay, see, a pathway mutation means what? Means in that pathway one of these will be overexpressed. Okay, overexpression of one of these. Okay, most of the time if PI3K is overexpressed, that means your BRF or AKT is overexpressed, and BRF somehow gets overexpressed. So BRF, MEK, ARK, see, these are all kinases, man, like MAP kinases, right? MAPK is there over here, see, like that. Okay, what they'll cause, see, I said, right, MAPK causes cyclin D. Okay, here, see, actually I don't know what is this, I'm sorry, I didn't do that. Okay, see, CDK, this is cyclin dependent kinases. Okay, I don't know, I didn't understand this part. Okay, I'll say it, just wait. Yep, I'm back. So yeah, CC, okay, this, I'm sorry, I'm so dumb. CC means cell cyclin, I know, I don't know how, cell cyclin D1. Okay, basically cyclin D1 and cyclin D1 with CDK4 and 6, we know that, right? And that causes proliferation. See, cyclin D cyclin, cell cycle progression. Okay, now I said you, right, P16 CDK4/6 inhibitor, see over here, CDK4/6 inhibitor. Okay, and see this your kit. Okay, so this thing is done. Okay, this whole thing is done. Okay, I explained you this also. I explained you the P10 what it is, and coming over here, that's how we are gonna do CDKN2A, P16 or INK4A, and P14, that is ARF. See here, familial melanoma or sometimes your sporadic melanoma is also caused. P16 is the negative regulator of cyclin dependent kinases, CDK, and P14 is the indirect activator of P53. How you know, right? MDM2. So yeah, that's it. I hope this helps, Ray. I think I'll remember it for the rest of my life. So yeah, again, tumor suppressor gene CDKN2A. That's a tumor suppressor gene. It's a locus on a chromosome. P15, P16, P14. Just remember 14, 15, 16. 15, I don't know what's the use. 16 is a CDK4/6 inhibitor. P14 is also known as AKARF. MDM2, it inhibits MDM2, so which in turn causes denaturation of P53. Yeah, inhibition, not inhibition. Inhibition of MDM2 inhibits denaturation of P53. Okay. Second is the P10 downregulation or mutation. P10 is which inhibits. P10 inhibits your PI3 AKT. That's right. Yeah, PI3 AKT pathway. PI3. What the fuck? Yeah, PI3K AKT pathway. Okay, kulps. Next one, oncogenes. Okay, oncogenes. What are these? Your RAS pathway or your PI3K AKT pathway or KIT receptor upregulation. So it's at different levels. Okay. So if I remove all this, see how will I see your problem. Fuck. Your problem could be at this level, the receptor level, or it could be before at the RAS level, or it could be in the signal transduction. But Prem sir, there's one more. Oh fuck, I'm sorry, Ray. Yeah, there's a third gene. Okay, I said right, one is CDKN2A, P10, and one more is a third gene. Okay, what is the third gene? Basically, it encodes for your telomerase. Okay, and so if your third gene is again inhibited or something happens to it, yes, you're fucked. So yeah, basically that's it, Ray. Not much. Thank you.